Welcome to my YouTube channel Be Technical. So I have recorded last lecture, I think a gap of 1 year before. So it's a very long time duration to record the another videos. So today we'll bring you a very important topic that is from higher mathematics, Fourier series. Many of us heard about this term Fourier series that is used frequently to solve many engineering related problem, and when you get the differential equation in complex form or higher order differential equation, at that time Fourier series is also helpful to solve that equation. So basically this is very important topic, Fourier series. It has a huge applications in engineering field to solve the problems. So you should know the basic concept of Fourier series and the formula used to solve this expression. So let us start. First of all, what is Fourier series? Fourier series is an infinite series representation of periodic function in terms of trigonometric function such as sine and cosine. So here two terms are important. One is periodic function and other is trigonometric function. So what is periodic function? Periodic function is a function which repeats its cycle after certain interval of time. So suppose you take any curve. Suppose I have chosen here sine curve and cosine curve. So after certain interval of time, this cycle is repeated. Okay, so this cycle start from 0 and go like this, again it is come here. So one complete cycle. After that again this cycle is repeated like this. Okay, so this is a sine curve and this is a periodic function. So periodic function is a function which repeat. It doesn't mean the cycle is like this curvilinear form. It may be like this. It may be like this. Okay, so it means that after some interval of time this cycle will repeat. That is periodic function. Okay, so here we plot the sine function and cosine function. Sine function, if you put sine function means sine x and cos x. If you put x equal to 0, then curve will start from 0 because sine 0 is 0. And if you put x equal to 0 in cos, then the cos function will start from here because cos 0 is equal to 1. Okay, so this sine and cosine function is a periodic function and sine is a trigonometric function. You should know the trigonometric function is sine, cos, tan, sec, cosec, like that. So Fourier series expansion is a representation of periodic function in terms of sine and cosine, that is trigonometric function. Okay, so periodic function like sine and cosine function you can also express in a series. You can expand this sine function, you can expand, that is in algebraic form. Okay, so cosine function you also expand. Here we write the expansion series of sine function, that is sine x. So it will be x minus x cube by factorial 3 plus x raised to 5 by factorial 5, like that. Similarly you can write for cos x. Algebraic function is also represented in periodic form. Suppose x square, x cube is also represented in periodic form, if provided that the condition is that after certain interval of time this cycle will repeat. Okay. So now we go to the representation of this Fourier series, how you represent or how you write the expression for Fourier series. So suppose fx is a function, we can write in Fourier expression for fx. So it will be like a naught plus summation of n equal to 1 to infinity an cos n pi x by L plus bn sin n pi x by L, and the series is from minus L to plus L. Minus L to plus L. L will be the any value. Suppose if you put L equal to pi, then this expression is valid for minus pi to plus pi. Okay, so this is for a general expression for Fourier series minus L to L, that is fx is equal to a naught n equal to 1 to infinity an cos n pi x by L bn sin n pi x by L. Here cos and sin is a periodic function, मतलब trigonometric periodic function, and an, bn, a naught, these three are the constant of Fourier series, a naught, an, bn. So there is a formula to find how to find this a naught value, an value and bn value. From that formula you calculate the a naught, an and bn values, put in this expression and find the this Fourier series fx. Okay, so the formula for this constant, that is a naught is equal to 1 upon 2l minus L to L fx dx, and for an 1 by L minus L to L fx cos of n pi x by L, and bn is equal to 1 by L minus L to L, means interval is minus L to L, fx sin n pi x by L. So these are the constant. From this formula you will find the a naught, an and bn values. Okay, so let us take an example. Before taking an example, if we put the value of L is minus pi to pi, then what will be the Fourier series? So find the Fourier series for minus pi to pi. Then again we go to this expression, that is fx is equal to a naught n equal to 1 to infinity an cos n pi plus not n pi cos nx plus bn sin nx. Here the interval is from minus pi to plus pi, means the values of x varies from minus L to L in previous case. Instead of L we'll put pi, so minus pi to pi. Then what will be the value of this constant, that is a naught, an and bn? So a naught is equal to 1 by pi, right, 1 by here a naught is 1 by 2l, so instead of l we have to put pi. So here is the 2 pi. A naught is equal to 1 by 2 pi minus pi to pi fx dx. An is equal to 1 by pi minus pi to pi fx cos nx dx, and bn is 1 by pi minus pi to pi fx sin nx dx. So we just put the value of pi in this expression. So we will get the Fourier series expansion is fx is like this, and the constant a naught, a and bn is like this. So now we'll first understand the odd function and even function concept. That is very basic. We already studied in class 12th. Based on that odd and even function, we can reduce our calculation. Then we'll move to one problem on Fourier series expansion. So basically, what is even function and what is odd function? So even function is a function, suppose fx is equal to any value, suppose fx is equal to x, then if you put in fx f of minus x, and it will be minus of fx, then it is a odd function, and if it is still fx, then it is a even function. For example, fx is equal to f of minus x. Okay, so f of minus x means it again is fx, that is called even function. And if you put fx is equal to f of minus x and it will be minus fx, then it is odd function. So suppose fx is equal to x square. For example, fx is equal to x square, and if you put f of minus x, so square of minus x is again x square, so it will be fx. So it is a even function. So x square, x raised to 4, cos x, this is the even function. Cos is also even function because cos of minus x is again cos x. Okay. So this is called even function. And odd function, sin x. Sin of minus x is a minus sin x. So sin x is a odd function, not even function. Again x, suppose fx is equal to x, and if you put f of minus x, it will be minus x. Okay, so minus x is, again we can write f of x, that is minus fx, means fx is equal to minus fx, so it is a odd function. Similarly x cube, x raised to 5, these are the odd function. Again another example is x into sin x. So if the function is x into sin x, means if you put minus x, so this is minus, and sin x is a again minus, so minus minus will be plus, so it is a even function, not odd function. And if you put x cos x, so f of minus x, x will be minus x, and cos of minus x is a cos x. So this value is minus, this value is plus, and minus plus is minus. So overall the function is odd. Overall function is in minus. I repeat, x, if you put f of minus x, suppose this is a function fx. If you put f of minus x, then this value is negative and this value is positive, because cos of minus x is a cos x, so this is positive, and minus into plus, so minus plus minus, so overall the function is odd function. So in this way you find the odd and even function of any function. Okay, so suppose if the function is even, then in the interval minus L to L, we know fx dx is equal to 2 times of 0 to L fx dx. This is a general integration rule. Okay, if the interval is from minus L to L and fx is a even function, then you reduce it, that is 2 times of 0 to L fx dx. And if the fx is an odd function, then this value of integration is 0. Value of integration from minus L to L fx dx is 0 if it is odd function, and if it is even function, then this expression reduced to 2 times 0 to L fx dx. Okay, so this is the concept of even function and odd function. Suppose fx is even function for Fourier series. In the Fourier series, if fx is even function, then the value of a naught is 1 by pi 0 to pi fx dx. How? Because you know the a naught is equal to what? 1 by 2 pi minus pi to pi fx dx. So in this expression, if fx is a even function, so it will be reduced as like this, then 2 times 0 to L fx dx. So similar way, 2 times, and there is a 2 pi, so 2 will get cancelled, 1 by pi 0 to pi fx dx. Okay, similarly an, now go to the expression for an expression is 1 by pi minus pi to pi fx cos nx dx. Okay, again here interval is from minus pi to pi, and the function fx is even function, so it will be reduced to 2 by pi 0 to pi fx cos nx dx, because the fx is even function. And go to expression bn. Now here bn, fx is even function, sin x is odd function, so even function, this is plus, this is minus, plus minus minus, so overall it is odd function. And from interval minus pi to pi, if fx is odd function, means total bn value total is an odd function, so the value of integral from minus pi to pi will be 0. So the value of bn is equal to 0. So the final expression for Fourier series is like that, fx is equal to a naught, because we have the value of a naught. If you integrate from 0 to pi fx ds, you will get some values, and similar way you can find the values of an and put those value in the final expression of Fourier series, we will get the fx, the series of fx. Similarly, if fx is odd function, so if fx is odd function, again you go to this expression, if fx is odd function, minus pi to pi interval, this integral will get 0, and if fx is odd function in an expression, then this is odd, means minus, and cos n pi x, this is plus. So overall overall function minus plus minus, so overall it is minus. Minus means odd function. So an value is also will get 0, because from interval minus pi to pi, if the function is odd, this integral value will be 0. So you will get a naught and an, both is 0. Now we move to bn. So bn is equal to 1 by pi minus pi to pi. Again fx value is odd, so it is minus, and sine x, so sine x, sine of minus x is also minus. So minus minus you will get plus. So overall the functional value is plus, means even. So we reduce this form, that is bn is equal to 2 by pi 0 to pi fx sine n pi x n pi dx. So you will get the expression for bn from this integral 0 to pi. You will get the some values of bn. Put this value in the series of Fourier series expansion, that is fx, so where a naught and an will get 0. So finally you will get the fx series is like this. Okay, so in this way you can use the concept of odd and even function, so that will mathematical manipulation will get reduced, and finally you will find the Fourier series expansion. Now here we take an example. Find the Fourier series of fx is equal to x. This is very simplest example of Fourier series. So fx is equal to x, as fx is odd function, because if you put f of minus x, you will get minus of fx. So fx is a odd function. So if fx is odd function, you see here in a naught and an will get 0. So a naught and an both constant will get 0. Only the expression of bn will required for Fourier series expansion, that is bn is equal to 2 by pi 0 to pi fx sine nx dx. So 2 by pi 0 to pi, what is the value of fx? Fx is x, so x sine nx dx. Okay, so here the integral is 0 to pi x sine nx, means two function. So you can integrate this by using integration by parts. Integration by parts. And what is the integration by parts rule? That is again the basic of 12th standard, that is u into v. So you apply the u into v rule, that is integration of u into v is you should write u and integrate the u is another function, v is another function. So first you put u as it is and integrate v minus integration of whole the expression, differentiation of u, integration of v, and whole the integration. Okay, so u into v is the integration by parts, means two function, and the function is can be written like this. So here u is the x and v is sin x. How will select this? U is x and v is sin x, sin nx. That is again the rule that is we studied in 12th, that is islet. Means you should take first inverse function, means select first function is according to this rule. First is inverse, again logarithm, again then algebraic, then trigonometric, then exponential. So exponential function taken as last. Okay, so first function is u. So u should be inverse function first. If it is not, then logarithmic. If again it is not, then algebraic. Here x is algebraic function, so u should be a. U should be algebraic, that is x. So you put in this expression of this integral. So bn is equal to 2 by pi. Here u is x and v is sin x. So put x is as it is because u is as it is. Then integration of sin nx minus integration of sin nx minus differentiation of u, that is x, and integration of v, that is sin nx, and whole integration of this x means u into v. So 2 by pi is as it is, x sin nx, integration of sin nx is cos nx by n and negative sign. Okay, sin and integration of sin is minus cos. Okay, that's why here is some multiplication of constant, it will go to in division. So minus x cos nx by n minus again integration of x is 1, differentiation of x is 1 and integration of sin nx is again minus cos nx by n dx. Interval is 0 to pi. So we'll manipulate this again. This value is as it is, and integration of cos nx is minus sin nx by n. So it will be n square, and this minus minus will get plus. Integral from 0 to pi. So you put simply this interval. So 2 by pi, you put the first higher order, that is pi, means upper limit. You put first upper limit values of x, then minus, then again the function of lower limit put, that is 0. So x is algebraic form, so lower limit 0. If x is 0, this whole term will get 0. If sin is 0, this whole term will get 0. So this whole value will get 0. So only upper limit value will come into picture, that is minus pi cos n pi by l. So if you put here we see the sin n pi value is 0. That is also the basic concept, that is sin n pi is equal to 0 and cos n pi is minus 1 raised to n. So this is a reduced expression for cos n pi. Again we put 2 by pi minus 1 raised to n by n plus 0. Again because sin n pi is 0, so this value will 0. This term will get 0. So 2 by pi will get cancelled. So finally we will get the expression, that is minus 2 by n minus 1 raised to n. So this is the value of Bn. This is the value of Bn. Put this Bn value in the final expression of Fourier series. You will get fx is equal to n equal to 1 to infinity Bn sin nx. So Bn value is minus 2 by n. Put this value here, and sin nx is as it is. Again minus 2 will get outside, and you can expand this series in you can expand this equation in a series form and put the value of n, that is n is equal to 1, n is equal to 2, n is equal to 3, and you will get minus 2 sin n is equal to 1. So sin x by 1 plus n is equal to 2, so sin 2x by 2 plus dot 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 like that. Okay, so this is finally the how to solve the Fourier series expansion. This is for homework. You can try yourself, that is find the Fourier series of fx is equal to x square. Okay, you should try this at home. Okay, bye bye, take care.